Welcome to Lecture 11. This week we're going to learn how to survey a building on campus at Fairmont State. We are going to survey engineering technology building. Our objective for the week is to understand how to survey and then how to begin drafting that as-built into Revit. As-built are existing construction conditions or as the building is built. And that's what we're going to produce. I use a running dimension line with my measuring tape whenever possible. I will explain how important it is to gather certain information when we are surveying a building. You want to note the construction of the floor and the ceiling. If it's a one-story, also the roof. And then start by looking around the first room. Before surveying, I like to have a quick sketch of what it is that I'm trying to obtain measurement of first, even if my sketch isn't perfect. It allows me to have a connection between observing, drafting, drawing, and comparing it to the final or building. And then I can begin the technique of measuring every wall length and opening. We're going to give ourselves the same sort of grid guides when we get back into Revit. You also need to note the wall types. Is this gypsum wallboard, GWB, or drywall? Is it brick? Is it CMU, concrete masonry unit? We want to note all of those items and take the measurement, if we can through a jam, of the thickness of the wall types. If you're surveying a stair, again, understand the shaft size, that overall shape. In engineering technology, it's a rectangle. And then observe whether or not you have any shafts, or if the landings on each level abide by that overall shaft size. You're going to note the number of risers, the length between the door and the first riser, the depth or the length of the landing, the height of the landing, and the height of the finished floor from level 1 to level 2 in our case. All right, let's take a look at what students produced in class for the measurements of engineering technology. We've done our survey in the same way that we observed our surrounding before we started measuring it and made a quick sketch. And that could be something that we see here drawn on the board. Kind of messy, but we're figuring out the room. The first thing we're going to do is take 2 overall dimensions. So let's keep that in mind when we start drafting. In the classroom, a left to right dimension that we received was 33 feet 2 inches. And a vertical dimension of 32 foot 4. We split into groups of 2 or 3 and surveyed 4 different areas. We found our way back into the classroom, and then the last hour was spent doing what we see here on the screen in Revit. We can go about the project and putting it in Revit in 2 different ways. I'm going to show you both in this video. The first way, in an hour, you will receive what you see on the screen. We will have a very small square just to give us a reference of dimensions. That square represents the classroom we see in the survey. You will have accurate wall types. It takes time in order to find the automatic walls that Revit gives us and conform them to exactly what exists on our site. So editing the wall types is technical and takes time. And then in the end, we begin drawing. And here we see the beginning of the classroom. I'm going to show you how to use that running dimension to copy a detail line throughout the page. And what I'm doing is I'm just notating, if we look on the right here, where the door is, where the wall recedes, where a shaft comes out. We used grid guides. We have an accurate wall type of gypboard, CMU, and brick, and an accurate stair. So this is the first way, and that's what we receive in an hour. I'll transition into Revit. And the second way, after an hour, you receive only a room that looks like this, built with generic walls. So either way is fine. It depends on what you want to achieve in an hour. Do you want to have an outline without accurate walls and go back in and fix them? Or get all of the walls prepped before you start initiating the drafting survey? So let's start with option 1. We determined that we had 4 wall types in our survey. If you're drafting a new home or a new commercial place of business, you determine how many wall types you will have in your project. I find it much easier to develop accurate wall types first and then use those in the drawing. So we need to edit the typical and automatic walls that Revit generates into something that's more accurate for our project. So we're going to start by just typing WA. Draw just one wall. I am in level 1. I'm going to touch the generic wall that Revit completes automatically as I start, and I'm going to search basic wall interior. And I'm going to select, because we've measured, the 4 7/8 partition. And so that gives us the accurate wall. Let's do a second one. Again, this time we're going to type in WA, and we're going to search CMU on metal stud. I'm just simply clicking the wall in the properties and then holding my cursor on the search bar, clicking and typing. And metal is abbreviated. All right, here we want to make sure that we choose CMU on metal stud. And then we're going to go into this wall and edit it so that we have exactly what we want. You'll notice too that I have changed the way in which I see these walls. If they're simply outlines, and remember the thin line tool, you can draw with very thick lines. I like thin lines, also use TL. But I can't really see the materials of my wall until I go down near the scale, and right next to that there should be an empty box. I'm going to click on that box and select Fine. Under the properties, we're going to click Edit Type. On the structural line, click Edit. Okay. Now I have my 8-inch CMU on the outside to work with. Okay. I want to delete rows 2 and 3. So when I select row 2, look below this menu. I'll hold my cursor on the button Delete. We're going to hit Delete once and then twice. So we're going to delete that membrane layer. Okay. So on row 2, I'm going to push the sheathing down. So cursor on level 2 and hit the down button. Revit needs to understand kind of what's in the middle of your wall, so it has that core boundary defining it. I do not have a 6-inch metal stud, so let's delete row 4. What your CMU on metal stud wall should look like when you're finished editing it. I'm going to edit type in the properties bar, edit the structure, expand this so we can read the wall. So what's left is a CMU unit in this wall type. I'm leaving the plywood sheathing to act as a hat channel for this lesson. We can leave the membrane layer. It has a 0 thickness, and then a gypsum wallboard finish of a 1/2. Even though we're in a commercial building, we'll leave this at a 1/2 instead of 5/8 today. Every time you change or delete items in your wall, you'll see that the total thickness updates. So you can check your total thickness against mine. Mine is 8 7/8 inches. And once you're done editing that wall, you can select OK. And OK again. Let's fix the last one. Basic wall exterior, brick on CMU. Make sure I got the right one in here. Basic wall exterior, brick on CMU. Okay. We ready? Let's touch that last third wall. We'll click on Edit Type. Click on the Edit button in the structure. All right. And for this wall, I am going to build a CMU with drywall, or no, CMU with brick and eliminate drywall. So I want to leave the brick. I'm going to go to the row 2 and delete air, and then go down to rows 7 and 8 and delete 7 and 8 so that I have just CMU as a face and brick on the other. So my overall total wall thickness here is 1 foot 1.5 inches. You will hit OK and OK again. The last wall type that I need is 8-inch CMU. Now, I already used a wall type with CMU that's very similar to just a plain CMU. So instead of going back and editing another wall, I'm going to select the CMU on metal stud, CO for copy, touch the wall, and move it here. If you want to name your walls so that you can remember what they are, we're going to do that by TX text. So just type TX as a keyboard shortcut, select the drawing, and you can type each of these walls. To get out of that command, simply touch the drawing again. Escape, escape to get out of that command. Okay, let's change this last wall type. So you'll see when I zoom in that originally I had a wall, a CMU wall with a hat channel and gypboard, and I've just deleted that in the wall type for my 8-inch. So here's the trick. Let's touch the wall you've already manipulated, edit type in the properties, and here's the trick. I don't want to change my old wall, so I need to create a new wall for this CMU. There's a button called Duplicate. I'm going to hit that, and let's simply name this wall 8-inch CMU. I'll do 2 since I've already created one. We're going to select the Edit Type button. And then all I want in this wall is the 8-inch CMU. And because I need to create things between the core boundary, I'm going to select row 1 and push it down so that CMU is between that core boundary, and then simply delete everything else. I will hit OK, OK again, and I have my pure 8-inch CMU wall. Okay. So congratulations. We have all of our wall types that we need. We're going to next draw just a simple square so that I can remember my overall dimensions. To draw any sort of drafting line, I use keyboard shortcut DL. I receive my drawing commands, and look, there's a rectangle. So we're just going to draw a rectangle on our sheet, and then we'll worry about its accurate dimension. So I've drawn a rectangle. I'm going to zoom in. To use the dimensioning tool, I'm going to select DI, touch the left, touch the right wall, drag it up, and select. I'm still in the command. Let's do touch the top wall, touch the bottom wall, and click outside of the square. Escape, escape. In order to manipulate the wall length using this dimension line, you first select the item you want to move. That dimension turns blue. I select the dimension line, text, and type in 33 feet 2 inches for my width. I select anywhere on the drawing to get out of that command. Again, let's do it on the bottom. I select the line, turns the dimension blue. We're going to make this dimension 32 feet 4. So I touch the numeric value, 32 feet 4 inches, enter. Okay, and now I have a guide to draw my walls from. If we look back in our survey, we're going to determine that the north, we'll call it Plan North, which is the wall behind which I lecture, and it's also adjacent to the far stair in the hallway. We have to look at what wall is that? And we determine that that wall is a brick on CMU because those who surveyed the stairwell say it is brick, it is thick, as we see in a projection of the wall in the hallway, and it has chipboard on it. So let's select that wall, CO for copy, and drag it into our drawing space. We're going to rotate this wall. We can do that 2 ways. We can select it, touch an end grabber and drag it, or Control Z changes it back, or I can select it, type in RO rotate, select anywhere on my drawing, type in 90 to 90, enter. Okay. I've given myself a guide here. I have a wall that I'm ready to work with. I'm going to give you one more guiding system to draft, and then we're going to make sure that it doesn't move on our page. So we can draw with what are called grid guides or grid lines in the Architecture tab of the ribbon. Look to the far right and you see grid. Of course, I'm going to use GR for the keyboard shortcut, GR. I'm going to select the left side of my page and drag right. Your number will probably be 1. Again, I'm going to select the left side of the page, drag right. I really want these to be guiding my overall dimensions of the classroom. And because I've already drawn that classroom, I could align the grids to that. Let's do that. AL for align. Touch the top line first because that's what I want to align to, and then select the grid line. I'm still in the command. Let's do it again for the bottom. Okay, so when I dimension the grid lines now, let's do DI. Touch one grid line, then the second, and touch my page. I should have an accurate dimension. Let's do the vertical next. So GR for grid. I'm going to touch low on the screen to start and drag up. And again, I'm still in the command. Touch low, drag up, and you have to really pay attention to how you're holding your mouse. I'm trying to make mine exactly 90. And place. I want these two items to be 33 feet too. So let's DI, touch once, touch twice, drag up. If I want to move one grid line using my dimension line, you can do it in an imperfect way by selecting the grid line and using your arrow keys to scooch it, or select the dimension line once the item you want to move is selected, 33 feet 2 inches, enter. So you could use grid lines, or you could use this rectilinear that we drew with detail lines, DL. In either case, once we have a set drawing, let's say I don't want to move it. I'm going to pin this to my page. So type in, first select the items. Again, to select something within the middle of your selection tool, click left, drag right. If you want to select everything you touch with your dimension tool, click right, drag left. But I don't want my dimensions in that. I'm going to select left, drag right, and type in PN. Hit escape if you like buttons instead. This can also be found in, in the Modify tab of the ribbon in the center of that page. So you'll notice there's a pin, and also there's unpin, UP. So you can do it that way too once items are selected. Why don't we pin the grid lines and then I'll show you how they don't move. So select your grid lines. If I want to add to my selection, I can hold Control and add. If I want to delete something from my selection, I hold Shift and choose it. I'll choose it back. I'm still in that Modify tab, and I can hover my cursor over the pin, and things are pinned. To unpin, you can simply select that object and hit the pin again, the thumbtack. Okay, let's say a few people are working on a shared model, and someone has set walls in a place that they don't want to move, but somebody else is accidentally panning and whoops, I actually accidentally grabbed a wall when I was moving. Whoops, That changes the room. I'll Control Z. You pin so that if I even type MV move and try to move this grid line, Revit tells me you can't move a pinned element. That's really helpful. I'll cancel out of that by hitting escape. It's really helpful when you're learning to draft because accidents happen without realizing when you're trying to do other commands. So we're just going to leave those pinned. So let's start building our classroom. And we're going to look at how we select different parts of a wall. Again, remember, if you want the materials on the wall to show, there's a little button to the right of the scale. Yours could be on coarse. Now your wall looks like this. Or if you hit the empty box, I like to draft on fine, again with TL, the thin line command at the top, a hot button. Okay. I want to align the inside face of my wall with the dimension I took. I'm going to use align, AL. Select the line I want everything to go to first. And then look what happens when I hover over my wall. Revit automatically says you want to select the stairwell face, the inside of your, the midpoint of our wall, or the face. If you can't get Revit to touch on what you want it to, hover over the area and select tab. And you'll see that I can actually select all of these items when I just touch tab. Okay, I want it on the inside face, so I select there. The locking mechanism does the same thing, sort of, that pin does. What the locking mechanism does is that if I click it and I unpin, save your project every once in a while too, and I unpin UP, my grid line. If the wall is locked to the grid and I move the grid, the wall moves too. That's also useful. But I'm just going to unlock it for now and leave my grid line pinned. Okay, let's align that wall to the grid 7 and 8. Yours are probably 3 and 4. AL, touch the grid and the end of the wall, grid and the end of the wall. Now we look at why it was important to use that running dimension. We'll go back to the survey. I've drawn the right-hand side of this wall in this bottom image, right? The top image, that wall is here, a little harder to read. We laid our measuring tape on the floor and we just went along and said, what does the tape read? So at the door jamb, it read 6 inches. At the other door jamb, 40 inches. Maybe 42, right, if it's a 3-foot door. But anyway, we saw 40 when we were measuring. At the first recess of the wall, 6 feet. At the shaft in our classroom, we read 20'8", right? This is all coming from this wall, front wall of our classroom. Other end of the shaft, 28'4". So this is one way of inputting this into Revit, still in that first command. I'm going to use a detail line to represent the 0 point of my measuring tape. So stick with me here. DL. Draw a detail line on grid line 1 or 5. Yours is 1. Hit escape 2 times. Now I have a line here. I can use offset or copy. And what I'm going to do is just offset from this line all of those other dimensions that I read in my survey. I like copy, but I'll show you offset first. So O, spacebar. Look above the drawing tab, offset at 1 foot. I know my first dimension is 6 inches to the jamb. I can type that there, hover over this line, and notice when I hover over the line, it puts it on two sides. So make sure you're on the right side before you click and hit escape. Touch that line again. Our next dimension was 40 inches. O spacebar, 40 inches. Hover over that line. Again, you have to kind of pay attention to which line it's coming from. 40 inches. So if you want something that's more precise, let's use copy. And let's remember the next two dimensions then. So bump back at 6 feet, shaft wall 20 foot 8. Why don't I minimize this a little? We can read it at the same time. All right, select that first detail line, CO copy, click the line, drag it, and you can type your dimension in here too. So 6 apostrophe for the foot, enter. 6 feet, same line, original line, CO, touch the line, 20 feet 8. Same line, CO, 28 foot 4. I'm just entering. So all of these lines represent where this right side wall of the classroom will move in and out or where there's a doorway. Right? So if we are aligning this same way we're looking, let's look in the top image and we'll see those lines represent the door, and then the recess in the wall, the shaft, etc. So let's build this wall together. It was noted that there's a CMU wall that surrounds the door entry. So let's go back, find our CMU wall. It's this one. CO for copy, select it, and drag it here. Let's use the Align tool. AL, touch the grid, touch the end of the wall. I want it to come back to this point because, let's look in our survey, that 33 foot 2 inches measured from the left to the right side of the classroom at this doorway, not in the recess. So this wall should align to this grid. Select the grid line. Yours is probably 4. And inside of the face, those walls automatically connect. And then let's align it to the 6 foot mark. 6 foot and back. I will dimension these here quickly, DI, so that you remember what each of the lines represent. I'm always going from the original line back. We'll move this one a little farther. All right, so those are all the copy or offset commands here. All right, CMU wall also moves to the right if we're looking at the drawing. And our image says that that dimension is 23.75 inches. So let's draw a wall that's 23 3/4 to the right. That wall was also noted as CMU. I can type WA. I know that that wall goes in this direction. I'm just going to put my generic wall there first. And remember our match tool. MA. If I select the wall I want things to look like first, and then select the second wall, it becomes CMU. I can draw a detailed line at the intersection or the end of my first CMU wall, drag it 23.75 inches, and hit enter. This gives me an idea. When I hover along that line, I can look for an endpoint. I'll go back in DL. If I'm drawing another detail line from it, I can make a mark. In any case, I think you'll be able to find the wall guide. I'm going to move, just select, hold my cursor down, and drag this wall up. I'm going to use Align tool, AL, select my guiding mark. If you don't have a guiding mark, maybe you can select the end point and touch the end of the wall. I'm still in my Align command. So I'm hitting the detail line there. And then I'm going to use Trim, TR. Select the part of the wall I want to keep on both sides. Okay, let's keep going. We know the easy door command, DR. A single flush is fine. I'm going to hover my cursor over my CMU wall and check the door swing. Mine is incorrect, so let's click the door, type the up and down arrow, and you're just going to center that because this door does not show a jam in that 36-inch dimension. Or 3'4" rather. No, never mind, 36. Okay. The rest of these walls here are either chipboard on CMU, if it's the straight wall in the hallway, or we have one shaft, which we determined was the interior wall. So let's grab both of those walls to finish this right side wall. I'll need a basic interior, and I'm going to need CMU on metal stud. Grab those, CO for copy, select the drawing, and move them over here. I can just grab a wall and drag it, and then let off the mouse button to arrange them more neatly. Why don't we save again? Couple ways to finish this from here. We can go kind of just piece by piece, and that's what I'm going to choose. You could also draw detail lines, right? So DL for detail line. And where this intersection of the face of this wall moves to the next edge of the shaft, we see that that's a 1 foot dimension out. So I could go 1 foot, enter, and I could erase my detail line if it's too many lines. DL, connecting here to here. It's 1 foot on the other side. So now that I understand where that mark is, DL, 1 foot, and to the back wall. I can do that and then look at the two different wall types. I'm grabbing, selecting them, and moving, and use my align and rotate and copy tools to fill this in. But what we really need to understand is that the detail line I just drew represents the inside face of the wall, right? Because I'm just going to align this shaft using AL. Because if we look at the wall and then we think about a plan, it's this inside chipboard face that I'm touching. And it's this inside line that I measured. So every time we align, we're going to align to that face. I know that the top and bottom edges, I'm just rotating, hitting 90, enter. All of these edges mean that the thickness of the wall is on the other side of the classroom. So you have to constantly be thinking, I'm in the class. That wall is behind my measurement, AL. Select that. I can TR trim, grabbing the parts of the wall I want to keep. I can touch the wall and even drag it back using the grabber marker. I can use my mirror tool, AL tool. Okay. And then the last wall that finishes off this drawing is the gyp on CMU. So let's go a little slower and we'll do the remaining part of the wall kind of piece by piece. All right. I'm going to touch my gyp on CMU and drag it to make it a little shorter and easier to use. I'm going to look at my survey. And my survey says, if I look at the image below, that the length from here to here, we can use the 14'8", which we measured twice in class, or that 20'8". If I didn't use my detail lines vertically, and I have DI dimensioned, that is 23 3/4, right? Or 23.75 inches. Okay, yes. I know that wall needs to remain that length. So I can align AL, end of that wall, to the front of this wall. I can trim TR. To move dimension lines, for some reason it grabbed the core of my wall. When you touch the dimension, if the dimension is small, or the ticker is small like it is on the left, grab the top bubble and drag it up until you see 2 dots. See what happens? It's the second dot I want to click, and that lets me, I'm going to tab, choose where on the wall I want a dimension. So I'm going to tab that back to the inside face, touch the dimension, and I can use the middle bubble of the text to move it out. I originally had my offset detail line. I deleted an earlier version. Right, and I know that that wall type extends all the way to here. I can do it manually just by grabbing the dragger. Those measuring the hallway told me this wall was straight the whole way. So I can bring that all the way down and even align it. And what I'm trying to think of is, if I just drafted that middle recess wall, I'm going to just continue drafting in Revit the shape, but not the accurate size of the room. So let's click on our last wall, then right click to create similar. I'll hold my cursor here. And then I'm simply going to draw what I know the shape should be, not worrying about the dimension of it yet. If the rest of you want to use your align tool, you can start to begin touching detail lines and aligning the interior face. We can dimension that last shaft. I'll do this again in a second, if you're at that point. And the rear wall is aligned. And I'll come around to see if you need help with certain arrangements. And then we'll work on the shafts together. I'll put my dimensions here, or you can look up at the board. And remember, the dimension at the back and the front are probably going to be different because we were measuring from the width of the doorway. Well, I'll leave mine here. Let's use a different wall type to draw our pilaster. I'm going to zoom out, and one of the first walls we drew was an interior wall. So basic interior wall 4 7/8. I'm going to left click on that and right click to create similar. And then let's just put it in the drawing. We'll dimension and make it better in a minute. So make a small U-shaped pilaster with walls. And there are 3 dimensions that you can look at. Can you all read the 90 inches on your screen? Yes, okay. So the shaft starts at 90 inches. I'm going to dimension inside face of wall to shaft. I might just move this down. If I click the top of the shaft first, then the dimension, I can type in 90 inches, enter, right? If it's easier for you to use 7'6", you can do that. I'm going to dimension face of the shaft to the wall. And I'm told that's 7.75 inches. And then the last one is 15 inches. Let's just put a few desks in here. I'm going to type CM for component model, and a desk pops up. So why don't you put a few desks? These seem to be different sizes than what we have, but that's all right. Okay. And then I'm going to take a camera view in my classroom. So go to the ribbon in the View tab. Find the drop-down menu below 3D View. And I'm looking for the camera. I'm going to touch the camera. And then I'm going to go to the lower left-hand corner. So I'm pretending like I'm Eric. Click once and drag the view of the camera shot toward the door, past the door. Click again, and we should be able to see our classroom. In my classroom view, I have really tall walls because we set the elevation to that 14'3" height. So why don't we put a ceiling in here? So in level 1, back in level 1 plan, so flip back from the 3D view. We're going to go to the architecture tab in the ribbon. And a few buttons in, 6 buttons in, locate the ceiling button. Click on the ceiling button. And when you hover your mouse over your room, if all of your walls have been trimmed and are connected, it's going to automatically draw a ceiling for you. So let's click, it should be turning red. Click in the room. And what it's saying is, hey, you're not in a ceiling view. That's all right. So to close the warning, just go to the lower right-hand corner and hover over the X, close it, and then look at your 3D view again. And it should look more accurate now. So I'd like you all to put the hallway into your computers on your own. Element hide, right? You can grab things and do EH. Yeah, I think it's 7. It's 7. See it again. All right, we'll just work for about 10 more minutes. You at least have one wall of the hallway here. Why don't you put a door in that wall? DR for door. And as you're putting in the door, it's around 16 inches or 1'4" from the inside wall. And then why don't we draw these walls with detail lines first so that you can use that method as well. I want you to draw a vertical line at 9 foot 10 inches from our backside of our classroom wall. So I'm just typing DL, drawing a line up 9 foot 10 inches, enter. Draw another line that's 19 feet 4 inches, enter. And then I'm going to highlight those two lines. I can click them both, hold control down. And I'm going to move them until they hit the hallway wall. You can do that with your arrow keys or MV for move. Grab an endpoint and drag it to the wall. All right, the inside face of the stairwell was CMU. So why don't you find your 8-inch CMU wall, right click, create similar. And then just draw a rectilinear wall outside of those detail lines, right? And then you can align. So that's kind of the other way of just drawing with detail lines first, finding the wall and aligning. So AL for align, touch the detail line first, and then the wall. And I'm going to move that into other walls. And then AL, touch the line, detail line first, then the wall. Line, wall, line, wall. Because if you do it the other way, the line moves. All right. And then you can use TR trim if any of your walls aren't trimming right. Good. And then I'm simply just going to touch my stair and move it so that the first riser meets 5'9" from that wall. So touch the stair, MV move, and I'm going to align it to that 5'9" and then push it closer to my wall. I'm going to double click on the stair. I'm just choosing one landing side and double clicking. That's going to get me into the stair command. And then I'm going to touch one set of risers. If I move with the grab bars, that just makes the stair wider. So just touch the whole thing, type MV for move, and you can drag it in or use your arrow keys to make it hug the wall. And then if you want to pull, touch the rise run and pull the grabber in. You might get error messages, that's fine. Anyway, it's filling up most of the stairwell and you can hit the check mark. I think if you have a space in between anywhere around 7 inches, You are good. All right, method 2. We opened a new file, found that architectural imperial architecture template, and we have a blank page to put our survey in. So this method is just put the drawing together, get an understanding of shape in Revit first. Don't worry about dimensions. So put it in there first, dimension later method. So if we just get going the same way we began our physical survey, we're just going to draw the outline shape of the classroom in the computer with generic walls. So let's type WA for wall. Our 8-inch generic wall comes up, and I'm drafting in Revit in between the elevation markers, those square and triangle symbols. I'm going to begin plan north at the front of the classroom, not worrying about dimension yet. Click. I know the wall goes down where the door is. I know the wall recesses right. It goes down. There's a shaft. Goes back. Down, and then the rest of the room is square. Okay. I've got a classroom. It's not the right size. That's okay. Let's use dimensions to make this more accurate. So DI for dimension. I'm going to select the interior face of my wall. To do that, hover over the wall and tap Tab a couple times until you get that inside face. And tap Tab again. You know, I forgot about the column in this wall. Looks like a pilaster, the column meeting the wall. Let's draw that before I forget. WA. I know it's small. Okay. Then let's take an overall front to back dimension, DI. Click the top wall tab to find the inside face. Tab and drag it out. Okay. Now I know this dimension from here to here is 33 feet 2. I can use a moving tool with the dimension to move that wall. The only problem is I can only move one wall with that dimension. That's okay. I'm going to select this wall. I'm going to touch the dimension. So wall was selected first. Touch the black colored dimension that turned blue. Type in 33 feet 2 inches. Enter. Wow. So I've drawn this really too large. If I want to make it just a bit smaller before I do my other dimensions, I'm going to encourage that. I'm going to select this whole series of walls. To select just the walls within the rectangle, I'm going to hover my cursor upper right, click, drag left, let go of the cursor. I can touch a wall, hold the cursor in, and just move my hand. If I select things in the opposite manner, like touching right, dragging lower left, it grabs everything that the rectangle touches, right? Compared to just what's in the rectangle if I do it in the opposite way. Why don't you take a minute? You can touch a wall, move it in, touch another wall, just drag. I'm just holding down the cursor, right? Because I realize that I've drawn this really way too large. Okay, so we'll make it a bit smaller compared to that first dimension. Okay. Let's do the second wall. I'm going to touch the bottom wall I can really touch either one, but I'm going to move it with the dimension I have here on the left. Touch the bottom wall. In my visual, that wall is 32 feet 4. If you look at the image on the right, I'm going to touch the dimension numeric number and type in 32 feet 4. Element is reversed. It's probably moving into my shaft wall. It's okay. I can say delete elements and we'll move on. Draw another wall later. Okay, so I have an accurate width, but none of the bump outs, right, or the shafts are accurate. I'm going to touch this low shaft wall and move it in a little, and then draw another wall to connect those back, WA. Okay. So overall shape is fine, but now I need to start focusing on the entry part. Why don't we start at the door? I show that survey in two different ways, right? This one is aligned in the same orientation of our drawing, but the picture on the bottom that we drafted on the board turns this wall 90 degrees. Do you see that? So if I have the door, I'm going to just type DR so that you have reference. If I want to move the door swing in or out, I can use the arrows to do that. All right. So we're going to utilize the same method that we used when we laid out the tape in the classroom. By using the running dimension, when we laid out the tape and read the numbers, we found the door jamb, if we look at the bottom image on the right, at 6 inches, other door jamb 40 inches, wall recess 6 feet. All of those numbers were taken off the 0 mark, that front wall of the tape. We're going to offset or copy using that same running dimension method when we draft. So hang with me here. This can become tedious. Let's start with a drafting line, DL. I'm going to select the interior face of this wall and drag right. The line, the detail line here, doesn't need to be any certain length. Okay, we do not want these two walls that we've perfected the dimensions on. We don't want those to move throughout our survey, right? Some things we want to maintain throughout. I'm going to pin those to my drawing. I can select one wall, hold Control, select the other wall, and type in PIN for pin. I'll expand this so that you can find the button as well. So when I select the wall now, you'll see that it has a little thumbtack. You can unpin it by typing UP, unpin, or Control Z to go back, or you can simply touch the icon. If you want to use the ribbon and a button, go to the Modify tab in the ribbon, and we're going to locate the pin in the center here, but you need to select the wall first and then touch the pin button. Now look, if I'm moving around in the drawing and I accidentally grab a wall when I'm moving, right? I can accidentally, while panning, move walls. If you're working with a group of people, maybe that tells you that your classmate or your colleague has put and placed something that they don't want to move if they've pinned it. You can do this as well. So if I even touch that wall and type in MV for move and try to move the wall, Revit gives me an error that says I can't move the pinned element. So this helps us not to make mistakes when we draft. All right, that's pinned. I have a detail line. We can use the offset or copy command in order for this to look like our guidelines in the survey, our running dimension. Okay, back in Revit. Let's use offset first. When I select the line, use O for offset, spacebar to get in the command. Look at what happens below the ribbon. We have an offset dimension. I'm going to change that offset to be 6 inches. Enter. And when I hover over this original line, depending on where my cursor is, above or below, I'm going to wait till it's below, it's on the inside face, and select. All right, I can continue to offset that line 6 inches. I'm going to hit escape twice because the next dimension is 40 inches. That's the other side of the jamb. I'm going to go from the original measurement, that 0 point on my strand, my first detail line, O for offset spacebar, change the offset to be 40 inches, enter, and hover around that first line. See the little dashed lines asking me which side do you want to offset. It can be a little difficult because you accidentally might grab another line when you use offset. So another option is copy. Let's move the door. So I see that that's the first edge of the wall, 0 point, 6 inches for jamb. Grab your door, hold down the cursor, and move it up. You can do this imprecisely by using arrow keys as well. So I'm just touching my up arrow to center that door in that 3-foot dimension. Revit doesn't have jambs on this door, so it's not going to be exactly aligned. That's okay. Okay, let's use the copy command to get this first recess on the right. I can touch my original detail line, CO for copy, touch the line, and remember that wherever you drag your cursor, Revit's going to put that dimension in that direction. So make sure it is perpendicular. Type in 6 feet, enter, 6 feet. I'll hit escape twice. Is the next dimension that we see in the running strand here. And then I can use my align tool, AL, to get that wall back to this point. I need to select the line I want it to match first, and then select the inside face of my wall. Tab if you can't find the right place. Inside face of wall, and then escape twice. Okay. So think about this. We measured inside of the classroom. So all of our measurements mean that the wall thickness is on the other side, right? So every time we have detail lines to guide us, these walls are going to align to the face we measured. Oh, that wall is pinned. It won't move, right? But I can select this, align, align, align. If this moved back, I would align that shaft like this, right? It fills out beyond the interior dimension we took. All right, I'll undo for all of that. Okay. So let's continue fixing this wall kind of piece by piece using dimension lines or offsets. Then we're going to move on to a stair. Okay. I look at my survey, and my survey says that the recess near the door is 23.75 inches. So 1 foot 11 3/4. Let's go in here and use DI for dimension. Select the inside face, hitting tab, inside face tab, and drag. Again, I can touch one wall, touch the dimension. Oops, said feet. Enter and receive an accurate dimension that way. But I can't move more than one wall. So if I try to grab all 5 of these, like 1, 2, 3, 4, 5, you'll notice that the dimension line doesn't change, doesn't turn blue. It will, if I move this with my arrow keys, it updates. So I can do it that way or hit MV and give it an exact dimension, like 4 inches to change it, or a foot back, MV. Again, I'm making sure my cursor is in the perfect horizontal line at 180. I'm going to move that back 1 foot, enter. Okay, but I can't manipulate it with a dimension if I grab more than one line. Okay. I'm going to continue offsetting my running dimension along the right side of the wall. So I've gotten up to 6 feet with that line. Let's put 2 more in, 20'8" and 28'4". Go to your original line, CO, touch the line, make sure your cursor is perpendicular, 20 feet 8 inches. Escape, escape. Original line, CO, grab, move down, 28 feet 4. Good. Now let's align that shaft. I'm making sure that I'm aligning the 2 horizontal walls, A, L, align. Touch detail line first. Inside face of wall. I'm still in the command. Detail line first. Inside face of the wall. Okay. Survey says here that that shaft wall is only 1 foot depth, right? So that's a little different from the door wall. So let's use dimension. DI dimension, tab to get the inside face. I'm going to grab inside face of shaft wall, touch again, drag up. Escape, escape. This needs to read 1 foot. These walls, maybe we pin them so they don't change, are set. So let's grab all of those. I just hit Control while selecting different pieces to add it to my selection. P-in to pin those. I don't want to move this wall. I've already made it the accurate dimension. I'm going to touch this shaft wall, 1 wall, touch the dimension, type in 1 foot, enter, and click on my drawing. Looks like both sides are 1 foot. So I can align AL, inside face of this wall, that I want the other one to match, and touch the inside face of that bottom wall. Okay, this is a good wall. Let's make sure the whole thing is pinned. Pin the last few, PN. Good job. In class, we had about 10 more minutes to get a stair in for both methods. So this concludes method 2 of inputting your survey. Just draw walls, put it in, fix it later. In this method, we still haven't had time to do the accurate wall types. So if you watch the beginning of method 1, you can figure out how to edit those. And what I mean is that this wall needs to be CMU and gypboard and brick. These will need to be blank CMU. This one is gypboard on CMU. Okay, let's do a stair. In order to tell the stair to go level 1 to level 2, we need to make sure that our stair understands the accurate heights of a floor-to-floor level. Let's look at our survey. We've been looking at the classroom. That's our hall, second stair, and this is the stair in the middle of engineering technology. Looks like we have a 14-foot 3-inch dimension from level 1 to level 2. So we're not yet working with the landing height. This is level 1 to level 2 dimension in Revit. Look in your project browser under elevations. Let's double click the east elevation and zoom in to level 2. I'll make mine back the way it is originally. Okay, zoom into level 2. By default, Revit has level 1 at 0, level 2 at 10 feet. To change 10 feet to 14-foot 3, you're going to select the dimension number once and twice. At this point, type in 14-foot 3 inches and hit enter. And Revit has updated your level to level. Let's go back to level 1. Remember, I can hold Control and just tap Tab, or you can find it in the Open Tabs drawings in your ribbon or the project browser. I'm going to move my dimension line into the classroom because I know that stair is just north of my wall. In the Architecture tab, I'm going to go and find Stair in the middle of the ribbon. Click on Stair, and now you see that we are in a command in Revit. We won't be able to get out of this until we hit that check or X. Most commercial stairs are going to be per the International Building Code. So what's nice in Revit, we don't need to measure every riser or run, as long as the floor-to-floor dimension is accurate and we know how many steps there are before the first landing. If we click on the Properties Assembled Stair, you'll notice that the template in Revit has 3 different types of stairs. In ET, we have an assembled stair. We took a look at the steel C-channel, the L brackets, the way the concrete metal pan was welded to the channel. So we'll allow Revit to go with the default 7-inch 11 tread option. You don't need to do anything. Okay. Revit draws stairs from the middle, right? So when I click the first time, notice that my cursor is drawn down the middle of that stair. I also didn't note because it was a default, but when you're trying to draw stairs at different levels, or maybe you thought, I just want to draw it to half level, you can manipulate, it goes from the base of level 1 to the top of level 2. You can offset things to draw different stairs to different levels or change the level. Okay. On my stairs, it was noted that to the first landing, or to the only landing, I only had 12 risers. So when I pull the cursor, I've only clicked once so far in this command, all the way out, I realize I've got 25 risers to work with, but there's only 12 before the first landing. So I'm going to move my cursor back to this point and click again. It stops the stair. Where you place the cursor again matters because I'm drawing the center of the stair, right? So If I accidentally have a cursor too close to the stair, it builds it crashing into it. I hit escape. So I'll pull this up, maybe if that's the center there, I'll pull this up like 4 or 5 feet more. Again, this method is place the stair in, fix the dimensions later. Revit will automatically draw a landing for you if you draw this line vertical from where you last clicked. Click again and start to pull your cursor. Also notice it matters what angle your mouse is drawing the stair at. If I don't pull this horizontally, it draws an angled stair and an angled landing. Okay, make sure your cursor's straight. Make sure you've drug it all the way out, right? Because you have to go to the end of that stair and click again. Great. To move the stair closer together, click the one you last drew. You can type MV for move, or you can use the arrow keys to do this imprecisely. Okay. Click on the side of the drawing and hit the check mark and zoom out. That was method 2. Earlier, we drew method 1. This method also has a stair now, and both classes are ready for the next lesson.
And you're going to dimension the face to face. And remember, we can use tab and just hover our cursor around the edge we want to dimension to. Touch there. Tab. Touch the front of that face. Drag our dimension out and click again. I'd like that wall to be 1 foot projection. So I'm going to touch the shaft wall, the vertical one, then touch the blue dimension, type in 1 foot, enter. So let's look at this wall. You're going to dimension, and when we're in the dimension command, we're going to dimension 2 things this time. So I'm going to do DI for dimension. Touch the interior of the front of the classroom wall, and then each outside face of the shaft. So I'm just continuing to dimension, and then clicking a 3rd time just to release the dimension. We're going to move to making accurate wall types. The walls that we've been drafting with are all 8-inch thick. And so they're going to overlap when we try to do small pilasters. So let's create accurate wall types before we move on. I'm going to tell Revit to do one more thing before we change the walls to be accurate wall types. I'm going to select the entire drawing. And then I only really wanted to pick walls in that selection. So do you see a filter in your ribbon above? Okay, I see some yes, shaking heads of yes. Let's click the filter. And I want you to uncheck everything that is not a wall and then hit OK. In the properties bar, the first white row says wall centerline. I want you to click on the imaginary, there's an arrow on the right side that you don't see until you click. We want to change that to finish face interior. I'll go back and do this all over again and then hit apply. To have the location line of finish face interior before you start matching walls. you need to make sure that the arrows on your generic walls are all on the outside face, so that when I MA match, find my interior basic wall, and click, it maintains the interior dimension of my room. All right, those aren't the accurate walls. Let's start to make whole walls more accurate to our wall types. That's the tricky thing about construction materials. It's understanding what we name it versus what its actual dimension is. Can be confusing. All right. So now the fun part. We're just going to match the walls we created to the walls we have in our room. So let's use the basic wall interior. When we get to the stair, we'll add on that wall type to the other side. All right. So let's use MA match. You're going to touch the wall that we want everything to be, that interior wall, and then hover our cursor. It moves my 32-foot 4 dimension out, and that's the wrong way. So to prevent that from happening, I just have to make sure the arrows on my wall are on the outside. So I'm going to match the top wall to the shaft. So it changes it from my 8-inch thickness to the almost 5-inch. And then if you still have your guides, you can align it back. And my pilaster is still not accurate, and that's okay. All right. Then let's work on these two walls around the doorway. 8-inch CMU. If I have those walls selected, I can go into the properties to type 8-inch CMU and change it that way as well. Let's hover over the CMU on metal stud, the second wall we created. And are we going to match? I think we're going to match that one to everything else. Yes. All right. So MA to start. We're going to zoom in on CMU metal stud. That was the second one. Click once, then go to your drawing. I know it's going to mess up all your dimensions. It's okay. And you're going to click the remaining walls. You want the drywall to be on the inside. We were talking earlier about the flipping walls. If you touch a wall, unpin it if it's pinned. You can click the arrow to flip the direction of the CMU. So just make sure all of the drywall is on the inside for these. And I'm UP unpinning. Right, let's adjust one more thing. Let's make sure our pilaster's in the right place. You can consult your phones. I'll pull this up here for a second. You can use my screen too. So I want this 11, yours is going to be something else, right? But I want the dimension between this wall and the front of the classroom wall to be 90 inches. So you're just simply going to select the wall, and then the dimension, you have two sets of dimensions, but it's the one with the black line. You're going to touch that numeric value and type 90 inches, enter. So for this command to work, you can only touch one wall. And then this is 15 inches wide. So I'm going to select the bottom of that pilaster wall, plan south. Hover over the numeric value of my dimension and type 15 inches. And then I'm going to dimension it so that I understand the projection. So I'm going to hit DI to dimension, hover my cursor over the face, hit tab so that I can select the drywall, touch the exterior wall. I think it's, okay, the depth is 7 3/4 inches. Do the next challenge on your own for about 20 to 30 minutes. You're going to draft the hallway. Well, you are. You can use what's on the board, or you can reference your photograph. Let's see. I have to leave mine small for you to see it, maybe. Okay. I can move this around as you wish, but like when we drew that wall that we just drew as a dividing wall between the hall and the class can be the same wall you use in the hallway. Does that make sense? Just to see what the feel of my room is like, see if it compares to what it actually is. So let's do CM component model. And up pops the desk. It's not as long as yours, but it will do. And mine allows me to place multiple desks, one after the other. I'm going to put 4. So you guys can fill up the room with desks. We have 4 rows. All right. Hit escape. Again, make sure you're in a level 1 plan. I don't know that you will be able to see what you're doing if you weren't. I'm going to take a camera view. So up in the ribbon, we're going to go to the View tab, and you're going to look for the 3D View button and the drop-down menu. Click on the drop-down menu, and you should see camera. So we're going to click on camera. And then we're going to position ourselves in our classroom as if we're in the back left corner. Click once and drag your cursor toward the door. So basically what we're doing is I'm saying, I am the camera and my view angle is out from me past the doorway. Click again. Yes. And we have a 3D view. All right. The thing that we notice, you can grab the little grabber buttons on the sides and make this wider, taller. But you'll notice that our ceilings aren't quite as high because we didn't draw a ceiling. So let's draw a ceiling and then we'll look back at our 3D view. Drawing ceilings are easy. So go back to level 1. And in the architecture tab of the ribbon, you see the ceiling? Okay, let's click ceiling. And what should happen is that when you hover your cursor in the room, if you have closed walls, you should see a little red outline. Click once. Because we're in the floor plan, we're cutting the plan looking down. We don't see the ceiling. So close the warning and then go back to your 3D view. Oh, now it puts it in as a default 8. if you want to be exact, whoops, hit escape twice, touch the ceiling, and then you see in the properties bar where it says height offset from level, you can make that 9 feet. And now it's exactly what we have here.
Okay. I'm in level 1, and I'm simply going to learn about a few different roofs by drawing them over the classroom. In the Architecture tab of the ribbon, we're going to look for the button called Roof. I'm going to click the roof. We can move it if you have that option to level 2, yes. And now I realize I'm in the command. We can draw roofs a few different ways in reference to our wall. Typically, I like to select the wall and tell Revit how much I want it to offset. So let's make sure that your icon is selected with Pick Walls. I'm going to look just below that area and above the drawing tabs to the area called Overhang. We want our roof to overhang a foot or 18 inches. So what happens if I pick walls at 0 is that it draws the roof right over my wall, and I don't want that. I'm going to Control Z, Control Z. I want an offset overhang of 18 inches. I'm going to type that in and hit enter. Now look, when I hover over the wall, just like the offset command, it shows a dashed line. I want my dashed line to appear outside of the classroom wall. So I'm going to select each of those 4 walls and then use my trim tool and hit escape twice, T, R for trim, touch the parts of the walls I want to keep, same here. Okay. So you'll notice on the pink lines that all of them show this tiny triangle. I'm going to select OK, and we're going to take a look at our roof, and you can click Don't Attach, and 3D if all sides have a slope. Go up to your hot button key. When I go into 3D, I notice that all of my walls are going up to an unconnected height and that they aren't attached to the level 2 at 14-foot 3 dimension that I created. We can fix that. And then we'll take a look at the hipped roof created in Revit. Let's use that filter tool again. I am going to select everything in my drawing, hit the filter tool in the middle of the ribbon, and uncheck everything except the walls, and hit OK. That allows the properties bar only to manipulate walls. And I'm going to look at the top constraint, click on the right side to get a drop-down menu, and click on up to level 2, apply. Okay, now I see that all of my walls are at the height of level 2, 14-foot 3. Reflecting back on level 1, I'm going to window tile WT. Actually, let me look at level 2 instead, because then I will be able to see the roof. I'm just element hiding the components of the drawing that we don't need to focus on. Okay, zooming in. So I see the classroom below and my roof now in level 2.
WT wall tile. In level 2, I want you to double-click the roof again. Each one of these walls has a slope on it. Let's touch the bottom. If I want this to not have a slope, I look in the properties bar, uncheck that, and it no longer has a slope when I hit the check mark. I had a hipped roof and now I want a gable. I'm going to select the plan north wall as well, uncheck defines roof slope and properties, and hit the overall green check. Now I can see that I have a gable roof instead of hipped. Now what are all these roofs and their names? Today we're simply going to focus on 2. The left 2 on the screen, an open gable, and that hipped roof. Let's do one more thing with roof. Let's attach the wall to the roof at the open gable. Revit makes this very easy for us. I don't need to wall edit. I will touch the wall that I want to connect to my roof, look in the middle of my ribbon, select Attach Top Base, then click the roof. Okay. Then I have a gabled wall. All right, but we all know this is not what ET looks like. Let's hit Control-Z to go back once. Double-click the roof a last time. Select the 2 remaining roof lines that define slope and uncheck those as well. I want to create a flat roof. Hit the green check mark. And now we have a flat roof that sort of looks like a floor and might be more believable for this drawing. Okay, that is the end of lecture 11. Take a few snip images and save them in your week 6 folder.